morning, also. Thank you for making it awake this morning, and if you came through the rain, to come through the rain. This is my first CFCamp. I am Kevin Goldsmith. I'm the Chief Technology Officer at DistroKid. We're one of the sponsors this year, and very proud to be a part of this community, a part of the CF community. You can tell in my talk today, I'll talk a little bit more about it in a second, but part of my title came from ChatGPT and part came from me. I don't know if you can tell which parts came from which. The don't quit your day job is mine. That's what happened. This is what happens if you put into ChatGPT, I'm going to give a keynote presentation about this. Please generate a title. This is the title it generates for you. So, and that is actually a little bit about what I'm talking about. When I was asked to give this talk, I talked to Gert, and well, what should I talk about? We at DistroKid are huge users of Lucy, have been since the beginning, but I joined the company in December. I worked at Adobe a long time ago, not on Cold Fusion, but I was Cold Fusion adjacent, so of course I did learn a bit about it. But I'm no Cold Fusion or Lucy expert. So I was like, well, you don't want to watch me struggle through CFML code. What should I talk about instead? And Gert said, well, a lot of people are a little worried these days about ChatGPT or other technologies. Maybe you should talk about that. And that made a lot of sense to me because one of the things I do is I mentor students for my university. And earlier in that week, I talked to a group of them, and one of them actually asked me, I want to be a software developer, but I'm not sure I should anymore because I'm worried that AI is going to take away my job. And I had never heard that before. So maybe some of you are afraid, maybe some of you aren't. But it's worth, I think, talking about this stuff a little bit. And that's what I want to do today. So just curious of you all, how many of you are actually using either a code assistant or ChatGPT itself in your daily work for coding? Awesome. That's great. How many of you are like, no, I don't need to use that stuff. That's just dumb. Okay, a few of you. So, I need to do, since actually I think Mark did a great job sort of talking about what DistroKid is, but because I'm speaking DistroKid, this is what we do. If you play since I'm assuming about half of you are semi-professional musicians, most of you would be very interested in using DistroKid, but this is what we do. We distribute music to streaming companies like Spotify and Apple Music and that kind of stuff, if you don't know who we are. Sorry for the very bad Lucy logo. You can tell I'm not part of Lucy. I'm just a supporter. I was going to say, so I can talk about DistroKid, but not the right audience. This is not a great audience for me to try and drum up business, but I can talk about Lucy and reinforce some of the things you heard yesterday, specifically about trying out Lucy 6 and contributing to that community. We are strong contributors to the community, and all of us working on it together just makes it better for all of us. So just wanted to throw in a little ad for Lucy instead of for DistroKid. Okay, so if you're looking around, you get this is something I pulled from Quora. Obviously, a lot of folks are a little bit concerned about this. You have things like this. All right. There's audio on this track, and I'm plugged in. Let me make sure.
There should be a jack.
No, I'm plugged into the jack. All right, well, you get the words at the bottom. So we don't technically need audio. Those of you who don't know, this is Rick Rubin, a very famous producer, music producer, produced a lot of famous acts you probably have heard of. Quick note, I used to work for Spotify. One day I was I worked in Stockholm. One day I walked past a conference room and there was this homeless guy sitting at the table. And I thought, oh no, what happened? Somebody got in, maybe I should call security. And then I said, well, maybe I'll walk past again. I walked past again, and Daniel Ek and Gustav, the CEO and Chief Product Officer, were now sitting at the table with him. And then I realized, oh, that's Rick Rubin. You see stuff like this, stuff like this. This is in Level Up Coding, a thing for us software developers. And this is from last week. We used to be talking a lot of fear. We used to be around no-code, low-code solutions. Now we get the convergence of ChatGPT, no-code, and then citizen development. Citizen development is another way of saying software development without software developers. So put us all out of a job. The thing is, this is nothing new, right? For those of us who've been around a while, I've been in software for full-time software developer for over 30 years. There's at least a few of you who've been doing it at least that long. You've seen this over and over and over again. ChatGPT and LLMs and all that kind of stuff is just the latest thing. There's a whole bunch of things that were supposed to put us out of work, get rid of software developers. Going back to like the 40s with these ideas of automatic programming. In the 80s, I was using TRS-80 BASIC or TI-99 4A BASIC, and I realized I could write basic programs that would write basic programs. And I thought I'd invented metaprogramming, and I was a genius, and I was going to get the Fields Prize or something. And then I found out later it was developed originally 30 years before I was born. But this was the first thing that was going to replace software development, was automatic programming. Then we get into BASIC, which is how a lot of us, certainly of my generation, got into software development. And BASIC came out very specifically because it was so hard to find software developers, right? It's not that normal people can't do it. Normal people can, but there's something weird about all of us, right? There's a way we approach problem solving. There's a way we approach logical thinking that's not unable, people can't learn, but it's not necessarily easy for people to do. And because of that, because it takes all the specialized knowledge, we're expensive. We're a lot of times in companies, we are the most expensive part of that company. And so folks are very happy to try and find ways to do stuff without us or fewer of us. And BASIC, especially back then, was really because there were so few software developers. The idea was, well, you can't wait on a software developer to solve your problems. Maybe we can all solve it ourselves. IDEs were all about making us more efficient, and it was for developers by developers, but also making us more efficient means you need fewer of us, theoretically. Intentional programming, I don't know how many of you remember this. Charles Simoni, who I worked with at Microsoft Research, built an entire company that later got bought back into Microsoft, where the idea was you would describe your business problems in plain English, and it would generate software for you. He made a lot of progress. He obviously didn't succeed, but now actually kind of ChatGPT is doing a lot of that for us. Artificial intelligence was going to take our jobs away a while ago, kind of didn't. Low code, no code was going to take our jobs away not long ago, still hasn't. And artificial intelligence, again, is going to come and take all of our jobs away any day now. I'm going to go through a very brief history of computing and how it relates to all this and why we shouldn't be afraid of new technologies. So before you even had the ability, if you think back to the 40s, what were computers in the 40s? They were these things that took up an entire building and had people in lab coats flipping switches to program them. And that's when one of the first programming languages came out, Fortran, 1947. And you might think, well, Fortran's kind of dead. What I'll tell you is before I was at DistroKid, I was at a company called Anaconda, which does a Python distribution, also a language that people use. But it's used a lot by sort of scientific programming, especially the Anaconda Python distribution. And if there's one thing you should know about the folks who do scientific computation, big data kind of stuff, it's all Fortran underneath it. That's the secret of Python, is that it's all Fortran underneath it. But this is still obviously in use, not as much as it used to be, but the whole point, again, really hard to find people to work and flip the switches. Let's make it easier for folks to do their work, means we need fewer of them. Didn't work out that way. Then we get into structured programming with COBOL in the end of 50s. Now we get into operating systems. Operating systems like Unix are really interesting because one of the things they're meant to do is make these large, at this point now we've moved into mainframes and mini computers. Instead of taking up a whole building, it takes up a big, maybe a floor of a building or a big chunk of a floor. But again, the idea was, let's make this using computers more efficient so we don't need as many software developers, so it's easier to program them, to get them to solve our problems. And that means that we'll be able to do the same amount of work with fewer people. What instead happened is it made it easier for people to use computers. They came up with whole new needs, whole new applications for them, which just then required more programmers and not fewer. Now, yeah, this gets a little busy, but hopefully you see it. Now we get into small talk and object-oriented programming, again, making software development easier. And I got to mention C because it's kind of important for history. This is a major change. So going from these kind of building-sized computers to mainframes and mini computers was a big step, but not as big a step as moving to personal computers. How many of you remember a time before personal computers? Okay, there's just a few of us graybeards. So what I can tell you was before, maybe not Apple II, but around this time, before this time, I was interested in technology as a young person. If you went to the library and looked up what a computer was, what you saw was people in lab coats looking very important, surrounded by big, big boxes. And that was my dream of like going and getting a PhD so I could be one of those people in lab coats, or maybe by that point it was more folks with like long hair and like flip-flops or whatever. But you know, work in the computer room. This changed everything. And a lot of these folks who were those folks who were the basement of the university or the basement of the company saw these things, and you could find all these articles in Compute and stuff that talk about, well, these are just a joke. This is just for kids to play games on. No one's going to do anything serious on these personal computers. This is just going to go away. And what happened is, well, kids played games and then wanted to write their own games and became programmers because some of those folks made the jump and realized what was happening. A lot of them didn't, but a whole new generation of programmers, like folks like myself, like some of you, came out once we had access to this stuff. It changed. Rather than having fewer programmers, again, we needed more programmers. Now we get into the 80s, graphical user interfaces. Again, Apple II, pre-Apple II versus Apple II, pre-Macintosh versus after the Macintosh. It changed everything. And it wasn't so much about programming. In fact, it made programming harder for those of you who had to start learning how to do stuff with GUIs where you didn't before, like myself. But what it did is it brought computing to everyone in a much more direct way. It was much easier to use than the Apple II. It was much easier to use than some of those earlier computers. What did that mean? We needed more software developers because we had all these folks still writing code for the mainframes. Companies still had them. We had folks starting to work on personal computers. Now the technology was becoming more accessible to normal people. What happens? We need more software developers. And of course, the next year, Microsoft Windows came out. Maybe less easy to use than first versions of macOS, but very, 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 very popular. Somewhere in here, now every person at a company has a computer on their desk, and they're trying to do stuff, but it doesn't quite do what they want. They need an application. They want to embrace this technology in their company. At the time, where you're going to write in Pascal, maybe C, not super easy. They need an easier way. There's not enough software developers. Their company needs custom software. Visual Basic rapid application development comes out. And again, at that time, I'm now already working as a C developer. I hear about Visual Basic and go, oh, that's cute. Basic still exists. That's funny. I'm not too worried about this as a software developer because I do very important software in C where I manage my own memory. And this is a cute toy that you can do some boxes on a screen. A couple years later, I end up working at Microsoft, and I find out there are more Visual Basic programmers in the world than there are every other software developer combined. There are many million Visual Basic programmers. I probably knew a substantial portion of the C developers in the world, because there wasn't that. It seemed like there were a lot of us. There wasn't that many of us. The whole point of this is it made application development easier because we needed more software developers. Those Visual Basic developers eventually became either Objective-C developers or C++ developers or Cold Fusion or CFML developers. And they're still going through and developing custom software for companies or building other software. It just created more software developers in the world. And now we get into the internet. Again, how many of you, all right, now we're getting later, how many of you remember a time before Mosaic? Okay. How many of you saw Mosaic and thought, oh, this is cute? And it's better than Gopher, right? It's better than FTP. That was me. I thought this was very cute. I'm like, oh, that's kind of cool. I had some friends that were going over to this new company. At the time, I was working for a company called Silicon Graphics. A few of my friends were going over with the CEO to this new company called Netscape that was just getting started. And they said, well, hey, Kevin, why don't you come with us? We're going to go do this cool thing. I'm like, that's funny. I mean, the internet stuff is cool, but I'm really a graphics guy. Oops. But at the time, that's kind of what it seemed like. Oh, this is kind of neat, but it's kind of cool, but not that interesting. A lot of us were wrong. I'm now just in internet for many years. Just everything I do is on the internet. Most of you, definitely if you're doing CFML. But there's, again, a new technology. In 1993, I don't think anybody thought this was going to replace software development. But as this started to grow, you started to see more articles about, well, desktop software is done. It's all going to be the web now. At this point, right, there were still mainframe developers. Lots of us writing either workstation or desktop software. The web's coming out. Eventually, people start saying this is going to replace desktop development. We'll need either fewer developers or we'll get rid of software developers altogether. Nope, what happened is we just now had desktop developers and web developers and mainframe developers, obviously fewer, but this was all still going on. We just kept adding more need for software developers. And of course, we got to talk about Java coming in here. This is where we started actually building languages really for web development. This was another thing. I was a C++ developer at Microsoft at this point. I saw Java, I'm like, that's cute. Maybe that'll be interesting someday. But it's just really like, you don't even manage your own memory. How can you do anything? Like, if you remember early Java especially, it was like, oh, you'd see the memory collector run. Like, your program would pause. And you go, this is a joke. I don't know how anyone's going to do anything serious with this silly language. We were wrong. But also in 1995, yay, Cold Fusion. And again, so now we're 95. It's still early web. If you remember this time, it's not a lot of stuff going on. There were a few websites, but not the zillions and zillions. Certainly not like it is today. But the time before, if you can just imagine, like back then, I was making some websites for personal projects or whatever. And it was pretty hard to do stuff. And if you actually wanted to talk to a database or wanted to do any sort of interesting things, it was actually really hard to do it. Cold Fusion came out, simplified things fairly dramatically, made it a lot easier. And for a lot of companies, this is where they really started to invest in technology and hire more software developers. And then right around there, about a decade later, we get into Web 2.0. The only reason I talk about Web 2.0, because again, this is where, if Cold Fusion and kind of Web 1.0 is like, oh, you can fill out a form and all the processing is really happening on the back end, what you've done is separate sort of the back end of an application from the front end, and we can use the web for a front end. When we get into Web 2, now the front end, the client, is now more of a sort of fully featured application. Again, this is where we start really seriously talking about the web itself is going to replace the desktop, and we'll all use web browsers. We won't use desktop software anymore. The world of desktop software is over. And instead, we have desktop software and web software and still a little bit of mainframe software. I bring up open source. Open source started before, open source started before 2000, but open source really, for those of you who were around for this time, like the way we talked about open source in this decade, in 2000 to 2010, really changed pretty substantially. And if you think about how critical open source is to what we do today, versus if for those of you who were working, like myself back then, where you would never touch open source with a 10-foot pole, because it was poor quality, because it wasn't written by IBM or Microsoft or whomever. It's a completely different world. And somewhere in there, right around this time, I was working in Microsoft Research. Eric Raymond, the guy who wrote Cathedral and the Bazaar, if you've ever read that, came to us, and came and gave a presentation. This might have been 2000, 2001. And Eric Raymond came to Microsoft, spoke to this massive group of us and said, open source is going to kill Microsoft. You're all going to be out of a job. All of you, because what's going to happen is we're going to give all the software away and people are going to write software for free. You're all going to either, I don't know what you're going to do, you're going to be baristas or something, but then you'll write software for fun in the evening and all software will be free from now on. That didn't quite happen, clearly. Instead, what now happens is companies write open source. We contribute to Lucy. Companies not only contribute to open source, but companies consume open source. It makes us more effective. What has it meant? Is there going to be fewer developers because all the software is given away? Nope, there's just more developers. Every one of these things that was supposed to either eliminate professional software developers or reduce the need for professional software developers has instead increased the need for professional software developers by giving us more power to do more things, to present more tools to people to use, more effective tools, more sophisticated tools. The kind of fundamental flaw of this way of thinking, and that includes things like ChatGPT, is the idea that what will happen is as the tools get better, as the technology gets easier, software developers will, we have invented everything. So now it's just about making what we've already invented easier to do. And instead, what do? We invent new things and make new tools that people can use. Can't talk about open source without talking about Git. And this is the iPhone, not part of open source, but it's an important thing. It's a whole new platform. When iPhone came out, you still had a little bit of mainframe, not much anymore, a lot of desktop, now web. Now you have a whole new platform. What does it do? Eventually we're only going to use our phones. We won't use desktop computers. Maybe we'll use some web, but it's the world of apps. That's all we need. Now we just use them all, and we use them for different things. More related to open source is Android that came out the next year, open source-ish. But this is, again, a new platform. Maybe next year we'll be talking about how we're all using Vision Pros, and that'll be the next new platform that we all use in addition to desktop and phone and web. I'm looking forward to Lucy for Vision Pro. And of course, we can't talk about this stuff, tools that make us more effective without talking about Stack Overflow. For those of you who have never lived in a world without Stack Overflow, let me just give you a little bit of taste of what being a professional software and developer in the 90s was like. I had a book that was this thick. That was my C reference manual that sat on my desk. It had lots of, highlighted and pages turned down, because if I couldn't remember how to do something, I had to go to an index and look it up and then go to the page and read it and then go, oh, that's how that works, right? And when the new version of C came out, I had to get the new version of the book. I also had multiple books that were this thick that were the Windows API guidelines. Now nobody does that anymore. We also get into cloud computing. Cloud computing, again, was this thing that was going to eliminate the need for data center jobs. Pre-cloud computing, pre-AWS, companies had big data centers. I worked at startups. I worked at big companies. I had to go to the colo and put racks or put machines in a rack. And when I worked at Adobe, you wanted to put a server, you need a new server, you had to requisition one, you had to put in a request multiple months in advance to go into one of the data centers. It was incredibly painful. What happened is AWS came out, and what was going to happen? Oh, everybody's going to know there's never going to be a company data center anymore. We're going to get, like, Amazon's going to take care of it. There's not going to be a need for systems people in your company anymore. You're not going to need networking people in your company anymore. You're not going to need data center people in your company anymore. It's all going to be easy and transparent. Instead, what happened is Amazon, Google, Microsoft, probably Rackspace had to build training programs to train data center people because they couldn't find enough of them in the world. They are hiring more of them than there ever was, and companies still have data centers, and probably I do know there's banks still with mainframes somewhere. And what also happened, we invented DevOps, and we invented SecOps, and we invented DevSecOps, and we invented MLOps, and there's just more of these folks now than there ever were. Again, new technologies, enabling technologies, what did it enable? It's not that big companies no longer needed data centers, it's that small companies now had access to this kind of stuff, which allowed us to build cooler stuff that people could use, requiring more software developers. And AI has been around forever. AI and ML being actually something you could build software with really started in the 2010s. It required data scientists. I worked at Spotify during this time. I worked at Adobe during this time. We had data scientists, but you had to go find your statistics PhD person to go and be a data scientist and surround them with data engineers to try and do anything kind of simple with AI and ML. Towards the end of this, we started getting more things like included in things like Amazon or Azure, making it easier, but still not easy. I advise startups, and I advise a lot of startups about like AI and machine learning. And if they wanted to do something that needed a little bit of machine learning, this was the thing where I'd say, well, you might be able to do okay with the built-in AWS stuff. It might get you a little bit, but you probably need to go hire an ML engineer to do anything serious. And actually, if this starts to become important to you, you should probably go and find your PhD person to be your data scientist, and probably hire a few data engineers, which for a smaller startup, that's pretty expensive. But this is what you needed to do. Today, oh no, okay. All right. Today you don't have to do that anymore, sorry. We're gonna do a super speed round to this. But today you have ChatGPT, and now some of the startups that I talk to about this kind of stuff, they just have a developer using some of these built-in, or some of these like OpenAI APIs, and they can build stuff that would have taken them months with a machine learning engineer, with a data engineer, data scientist. They can now do it in a day. There's a company that I work with that had struggled to build machine learning stuff for a long time, and they wanted to do this thing where for their customer support, they would actually be able to summarize some of the conversations, understand sentiment analysis, and you could do some of it with some of the existing tools, but they're really struggling to do it. They had their data scientists working on this problem, and they eventually kind of gave up, and one developer in the afternoon downloaded a large language model that they could run in their environment and built that feature in an afternoon by themselves. Right? They're not machine learning engineers. They don't understand this stuff that much, but they actually got reasonable solutions out of this. Does that mean we don't need data scientists anymore because ChatGPT or large language models have solved the problem? Nope, we totally need them. We just need them to do more important stuff. And they get to do more important stuff, and we'll need more of them than we did before, because now we can do all this cooler stuff. Now we can put, CFML on a virtual screen and sitting on top of your desktop, or whatever. And just think for a moment, because I think we lose this in our day-to-day lives, what it actually means to be a software developer, to build CFML stuff today. Like just how much we get to take advantage of that didn't exist not long ago. So let's say you're just doing something very, very simple, like a CFML hello world, right? And you're like, okay, well, I'll just put this in this little Lucy thing. Well, if you're doing that, you're running on top of Java, which is running on top of the JVM, which is running on top of Linux. Well, probably if it's running in AWS, it's probably a virtualized Linux, which is running on another Linux, which is running on C, which is underneath is C, and then assembly, and then on top of hardware. So your little hello world is living on top of all these things. You're standing on the top of a mountain, and you get to do stuff that 20 years ago, 15 years ago, would have taken you a year to do. Just a little bit, not hello world, because hello world wouldn't have taken you that. Hello world to console wouldn't have done that. But to do all the things that you just get to take advantage of and take for granted, this is all the stuff. But of course, you're not just doing it, you're delivering it to a web browser. And that web browser is, okay, well, that's cool. I'm just giving you a little HTML. Well, maybe you're actually doing a little JavaScript because your hello world is bouncing around the screen or something. And maybe you're even doing something sophisticated like WebAssembly, which is just another virtual machine running on top of the web browser. And in fact, that web browser is running on top of an operating system, which is running on top of C, which is running on top of assembly, which is running on top of hardware. So if you just think my little hello world that's bouncing around your browser, just think of all the things that you get to take advantage of that we didn't a long time ago. The amount of power you have today, and then if you think about the amount of power, what can you do with that in the next few years? And of course, I got to say, yeah, this is, if for those of you like, well, that's not really how this works, there's a lot more to it, or yeah, of course, I'm oversimplifying it, but that's the point. It's actually more complicated than this. I'm simplifying it. And again, you don't have to think about it. It's just there for you. You don't have to worry about it. It's just built in. And I think we tend to forget about how much we get to do and how powerful the stuff we have and what it's going to be like in a few years when it's even more powerful. What are we going to be able to do then? What do we get to take for granted? So us as software developers, new technologies don't displace us, but we're always being told that they will. We're constantly being told that these new technologies are going to displace us, but that's not what happens. They won't displace us unless we let them, right? They won't displace us unless we choose not to adapt, right? So what's the story? If you were a mainframe developer in the 70s and you saw these personal computers and you say, well, that's cute, that's stupid, that's dumb, that's a toy, I do real work, and you say, I'm going to be a mainframe developer forever. What happens? Well, personal computers come out, there's fewer and fewer mainframe jobs. If you refuse to sort of adapt to the new way of working, you end up out of work. But it's not because we need fewer software engineers or fewer technologists. It's because the world's changing. We need to be adapting. If I had continued to say, well, I'm a graphics workstation person. I only work on hardware that costs like $250,000. This web thing is cute. Go ahead and play with that, but I'm doing the real important, serious work. Well, I don't know what I'd be doing anymore, but probably not working in our industry. So the important point of these things, ChatGPT, which luckily most of you are choosing to use and take advantage of, is these are all things that make us more powerful and things we can choose to adopt. And if we don't, we end up in trouble. I'm going to tell a little story. One of the things that really struck me in the keynote yesterday was, I think, the biggest applause line for Lucy 6 there's tons of cool stuff in Lucy 6, but the one that got the most applause was that the config file is no longer in XML, is in JSON. And like, yeah, yay. And I remember thinking, like, what's wrong with XML? It's a file format. What's so wrong with it? But it made me think about, when I'm not going to tell you too much of the details of this job because I'm talking about a real person and I don't want you to know who I'm talking about. Because if you know this space, you actually probably would. I worked at a company, I joined this company a while ago, and I got sat next to, my office was sort of next to this guy who'd been at the company a while. And I met him, I was trying to figure stuff out. He was incredibly nice to me. We didn't work on the same team, but he was really, really helpful, became a friend. And what I found out eventually is he was one of the world's preeminent XML experts. He was on every standards committee. He'd been part of SGML. He was, he did XML for the company, but he was, again, sort of a world expert in it. And he was telling me, they kept, people in the company kept telling him, maybe you should start looking at some of these other things, right? There's all this other stuff going on. Maybe you should start looking at some of these things, or you could take your experience and your knowledge and help apply it in these new spaces. And he's like, no, what are you talking about? I'm on all these XML committees. I'm doing all this very important work for the company. Look at this stuff we've done to XSLT. Amazing how amazing it's going to be. And eventually he got laid off. He got laid off because the company was like, we're good with XML, thank you. And we've been telling you, maybe it's time to look at something new. You don't want to. Okay, well, we don't need you to work on XML anymore. And if you don't want to work on XML, then maybe you don't need to be here. And it was really tough. He'd been at the company a long time, and he thought he was generating all this value. And what he found was when he left the company, no one else needed an XML expert anymore either. Because, it's not that we'd kind of reached peak XML. And I felt bad for him. He ended up retiring early, and luckily he was able to do that, but it's certainly not the way he wanted to leave the industry. And it was very telling to me, because at the time, I was like, well, this is what I do. I'm a graphics person. This is what I do. This is the only thing I do. And it really made me think about this stuff, right? Whatever we are working on today, maybe it'll still be around, maybe it won't, but we need to pay attention and to think about and to see what's coming and to adapt to it and to take advantage of it. And I learned that lesson from this person. And it informs a lot of this conversation that we're having today. So we need to leverage these tools. A lot of you are leveraging ChatGPT already, it seems. We need to leverage these tools to build better things. It's not about replacing what we do. It's about helping us do new, cooler stuff. And if you're, some of you are maybe doing this kind of thing, we are using specifically ChatGPT, but also some of the coding tools, the AI coding tools at DistroKid. It's easy. It's great for automating the easy stuff. So I don't know how many of you have ever had to build a login page in CFML, but this is what ChatGPT does for you. It's pretty redundant, right? You've done it a million times. In my life, I've written XML parsers or XML generators or JSON parsers or JSON generators or graphics file formats, things over and over and over again in different jobs, because you always end up having to do that until we got open source libraries to take advantage of for it or got built in. But yeah, so you go, okay, well, let's say you're working on a new project for a new customer, and you need to build a login page. Okay, well, you could take your boilerplate or copy and paste from some other project, or you could ask ChatGPT, and this is just me saying, just give me a Lucy component for a login page. And you can go, well, of course, like ChatGPT is missing all the security stuff and all this other important stuff, but no, it knows it is. And it's going to tell you, yeah, by the way. And you can then come back and say, well, please, you know what, give me the same login page, but actually, please let me not store the password in plain text. I hear what you're telling me, ChatGPT. And if you're a junior developer just learning CFML and trying to figure this out, and you start with this, maybe you didn't know that you're not supposed to store your passwords in plain text. Maybe you didn't know that you're supposed to be doing input validation to avoid SQL injection. These kinds of things, it actually makes you a better programmer. And again, who needs to write a login page from scratch in the year 2023? So automating the easy stuff. So much of what we do and so much of what we've always done is boilerplate stuff. It's really boring. Like 50% of programming is doing the same boring crap we've done every other time we do a project. So, all right, let's not do that anymore. Let's outsource that to an AI. Documentation explanation. I have managed software developers for 20-something years, 25 years, maybe longer. The number one thing I constantly have to say is, please document your frickin' code. Please add some comments. Please put something better than I did the thing with the thing instead of the other thing in as your like PR comment, right? Nobody knows what you're talking about. No, you in 6 months are not going to know what you were talking about when you're trying to figure out which check-in broke that thing. Maybe it's the one that says I did the thing with the thing instead of the other thing, right? Maybe it is, maybe it isn't. You know what? It's pretty good at like looking at your code and telling you what it did. And it might surprise you when you find out, oh wait, that's not what I meant it to do. I don't use Stack Overflow anymore because I don't need to. Stack Overflow is great. Again, like Stack Overflow really changed how software development is done because it made it easy to look up how to do the things instead of having to tough it through for every person in the world. But you would get a generic answer to your problem. Maybe it would be helpful. No, instead now I use like ChatGPT to get a very specific answer. And then if I don't like the answer, I can tell it I don't like the answer, and it gives me a better answer. And like the example I gave, machine learning, being able to use machine learning in your applications is now easier than it's ever been. It used to be really hard. It got a bit easier if you want to do the simple things, but now you can do a lot of very sophisticated things without having to go and hire a machine learning company or go and hire a complete machine learning team. If you get serious about it, you're still going to do that. So it's not like like I said, it's not like we're getting rid of machine learning people. It's just available to more of us than it ever was. I haven't talked so much about low code, no code, but this was a very scary thing a few years ago. I don't know how many of you get involved in this stuff where you're working on the early prototypes, maybe to show a customer, maybe to show somebody inside the company. It's kind of fun. It's kind of a fun programming task to build a fun, cute prototype, but honestly, it's a waste of your time if you can just throw a tool. And a lot of the design tools already have kind of prototyping built into them. But if you don't have to write the prototype, you can focus on the more valuable, more important stuff, and then just consult a little bit. Good use of your time, better use of your time. Simple applications, a lot of you, me, have worked with other departments where like, oh, we really need a thing that connects these two data sources. Can you write this for us? And you can, or you could use IFTTT, or you could use Zapier and not have to do that, which would be great. You could be working on much more valuable software for the company than some of the simple applications that you need to do for accounting or marketing. And similarly, for those non-technical teams that need little stuff and like you're trying to do important things and you got folks in other departments calling you saying, hey, can you do this thing for me? Can you do this thing for me? You can say, you know what, actually here's a tool that'll let you do it for yourself. And if you need help, let me know. And I can go and focus on more important stuff. So I asked ChatGPT to give me good sources. It didn't have any, but this is what I found, and also with Googling. I wanted to find sort of the number of software developers back to the 40s. That data is not easily available, but I have it from 2018 on. But I can tell you anecdotally, like I said, I've been in the industry, been full-time software developer in the industry for over 30 years. I don't remember a time, except maybe 2000, 2001, where it felt like the industry actually contracted a little bit, where I knew people who wanted a job and couldn't find one. I know lots of companies are laying off right now. I know companies are laying off not necessarily software developers, but other roles and saying, well, we don't need them anymore because we have AI and machine learning now to replace them. But if you look at it, even during COVID, where folks were laying off, the number of software developers grew. And you can, like I said, the only one that feels like maybe it wasn't the case was 2000, 2001, but really, this number has always grown. I'm not going to say, well, it'll grow forever and ever and ever, because eventually the entire human population will be software developers, and that's not practical. But I don't think we're going away anytime soon. And a couple years ago, this Future of Jobs report from the World Economic Forum actually was pretty bearish about software development. This was sort of the height of, if you remember at the beginning of COVID, a lot of companies contracted because they were worried before they started growing, and then they all started growing, and then they grew too much, and now they're contracting again. But they actually came out with a report that said, well, you know what, actually maybe software developers, there's going to be fewer of them, or not going to be as big a role. This is the current one, just came out. Instead, it takes a little bit of a different approach, saying that technology, the impact of technology on jobs is going to be a net positive. within technology adoption, big data, cloud computing, AI feature, likelihood of adoption, more technology, key driver of business transformation, fastest growing roles relative to their size today are going to be driven by technology, digitalization, and sustainability. So basically, the World Economic Forum went from saying, maybe we won't need as many software developers in the future to saying, no, next 5 years it's going to be just bigger and bigger and bigger. And I didn't have a good way to kind of find the number of job postings. Even we've laid off, the big companies have laid off, I think, over 100,000 to 150,000 software developers in the last year or something globally. But in the US alone, there's 190,000 open software development jobs on LinkedIn. So it seems like we're still more jobs than developers. I don't think that's going to change anytime soon. So again, we don't fear technology. We love technology. That's what we do. We don't fear technology. We don't fear new stuff coming in, taking our jobs, because what we do, we conquer technology. That's kind of what we do. We learn how to use new technologies as tools. We learned how to adapt, to take advantage of this stuff, to just do better things for people. Oh, oops, sorry. All right, it's a little joke, a very little joke. Thank you. So, I just want to leave you with that thought. You're all, most of you are taking advantage of these new stuff. Keep doing it, keep paying attention, see what's coming next, take advantage of it, and use it to make better software. Thanks everybody.